Hello again, everyone. Welcome to our third installment of showing you how to solve these basic Kakuro puzzles. As you can see on the screen here, this week I want to concentrate on what I call the 3 and 4 option pairs, also looking at 0 option runs. We've gone through a little bit last week, but I want to use it a bit more in adding and eliminating numbers from the rows and columns. And I also want to show you keeping to use the check button and keeping using the prompts to help us as we go. Now, at the end of this exercise, we should be at a point where we really know everything that there is to know about solving pairs. And I actually also want to put up a couple of charts that I'll show that explains probably in a bit more detail or give you more of an idea how you can remember these things a bit easier, or how they will you can figure them out without having to use the prompts. But for now, we'll keep using the prompts, and I just want to go through some of the exercises that we've gone through in the previous couple of videos and quickly establish some patterns on this particular puzzle again, which is another 9 by 11 easy one. So let's start at the very top. Okay, we can click on this one. 2 that add up to 5. We know that it can only be 1, 2, 3, or 4. One has to go with the 4, 2, and 3. So let's put those numbers in. It can only be 1, 2, 3, 4. Here can only be 1, 2, 3, 4. Now then, because we've got these established, we can work out the other side. I know that this is adding up to 12, so it can't be 1 or 2. I can eliminate that straight away. Can't be 1, can't be 2. So on this side, it means here, this cannot be 4, and it can't be 3. If that's a 4, that has to be 8. If it's a 3, it has to be 9. Okay, now, 2 numbers here that add up to 7. If that is a 2, then that has to be 5. If it's a 1, it has to be 6. Now, look straight away here that the number that we're looking for is a target of 23, which is the second highest run with no options. And we know from that that number has to be 6, 8, and 9. It can't be a 5, so we can eliminate that. We know that that has to be 6. If that's got to be 6, this has to be 1 to make 7. If that's 1, then this has to be 4 to make 5. That's got to be 4 to make 5. If that's 4, then this has to be 8 to make 12. So we've now got 6, 8. This has to be 9. 9, we've already got it established, so the other side of that pair has to be 4 to add up to 13. Because we've got 4 established, this then has to be 8 to make 12. 8 means that this has to be 3 to make 11. 3 means that that has got to be 5 to make up the 8. So we've already got a quick batch of numbers already put in. Okay, now let's go across here with other ones that we've learned before. Quick one here, I think we mentioned it last week. We've now got a run of numbers here. 1, 2, 3, 4, 5, that's got to add up to 15. Now, if you add up the smallest numbers that we can get, which is 1, 2, 3, 4, 5, lo and behold, they are the numbers that we need to make 15. There's no other options. All we've got to do is work out which way that they go around in there. Now, you can put them in and eliminate them later, but as you get more and more experience, you can actually just not bother putting them in the first place if you look at the tangents. So I just keep in my mind 1, 2, 3, 4, 5. I know that this can't be the 1 because you can't have 1 and 10. So in here can only go 2, 3, 4, 5. This can only be 1, 2, 3, 4. This can't be 1 or 2, so this can only be 3, 4, or 5. This can only be 1, 2, 3, 4, or 5. This has to be 1, 2, 4, 5 because it can't be 3. Now we can go on the tangents from here. If that's a 5 to make 11, it has to be 6. If it's a 4, it has to be 7. If it's a 3, it's got to be 8. So I can stop there because we're looking for 2 numbers that add up to 8. So I know that it can't be the 2, and I know that it can't be the 3. It can only be 7 and 4 or 6 and 5. That also means here that if it's a 7, it's got to be 1. If it's a 6, that's got to be 2. And it's the same way when we're looking here, I can eliminate the 1 and 2 because I know that it can only go with the opposite pairs. When we're now looking at the two numbers that add up to 12, if it's a 5, it's got to be this 7. So I know it can't be a 7 because we're looking at the top two pair here, which has got to be 8 or 9, 8 or 9. So it can only be 3 or 4 to add up to 12. I can eliminate that 5. Okay, so now I'm looking here. Remember, we can say that we can eliminate them. You can eliminate pairs. I'm looking here at eliminating 3. I've got 3 boxes here that have all got the numbers 3, 4, and 5, and there's a matching pair. So I know that that cannot be a 4. You can't have any more 3s or 4s on that line. So that eliminates that now down to 5. So down to 5. So I now know that we can't have 3, 4, and 5 on the rest of this row. We can eliminate that. Can't be 4, 5. Can't be 4, 5. It's now down to 1, 2. So because this is 5, this has to be 6 to make 11. Because this is 6, this has to be 2 to make 8. Because this is 2, this has to be 3 to make 5. 3 cancels out that 3 to be 4. 4 means that this has to be the 8 to make 12. This means that this has to be 9 because it adds up to 17 and you can't have any matching numbers. So it just cancels each other out. We can get rid of that 3. So we're looking at 1 and 2 here. So the tangents, now we know it can't be 3. 2, it has to be 4. And if it's 1, it has to be 5. So now that means that this can only be 7 if it's a 5 and 8 if it's a 4. Okay, let's carry on down. This is going to give us a few options in 9. 14, we know it can't be 7. So remember before is that the only options it can be is 5, 6, 8, and 9. So it can only be 5 going with the 9 or 6 going with the 8. Let's put those in. 5, 6, 8, 9. 5, 6, 8, 9. Now we know that we've already established a 9 here, so that cannot be 9. If that can't be 9, this number here cannot be a 5 because it's opposite pair. So let's work out the tangents here. If that's a 9, this has to be 2, which I know it can't be because we're also looking for a pair that's adding up to 4. So I know that that can only be a 1 or a 3. This can only be a 1 or a 3. So in this square here, I know it can't be 1 because you can't have 1 and 10. So we've narrowed it down straight away to 3 and 1. And because that's 3, then this has to be 8 to make it 11. And 8 means that's got to be 6 to make 14. Now we've also established here a 1, so this can't be 1. That has to be 2, making this the 1. Because that's 1, this has to be 5 to make the 6. Because that's 5, that has to be 7. There you go. So we've now got basically a corner going. We're well on our way. 8 will give us a few options. We'll get to that later. That's a few options. 4 can only be 1 and 3. This can only be 1 and 3. If that's a 3, that has to be 4. If it's a 1, it has to be 6. Let's carry on now. Okay, we've now got a triple. The lowest triple we can get, which is 6, which can only be 1, 2, and 3. So we can put them in. But at the same time, I know that it can't be the 2 because we're looking here, crossing it with the 4, which can only be 1 and 3. This can only be 1 and 2. This can't be 1, and it can't be 1 and 2, so this has to be the 3. Because this is 3, this is 1. This one here has to be the 2. And this has to be the 1. Because this is 1, this has to be 4. Because this is 1, this has to be 3. Now we can now add up. 3 and 4 is 7 and 1 is 8. 8 and 6 is 14. 14 and 9 is 23. That's 25. That's now 32. So we're just missing an 8 from there. Okay, we can check that up and put it through there. So 1, 2, 3, 4, 6, 7, 8, 9. We've got 1, 2, 3, 4, 6, 7, 8, 9. We're pretty right there. Let's hit the check button and just make sure at this stage there are no mistakes. There we go. It's cleared through. We're well on our way now. Let's get back to where we were over this side. We're looking now for a 1 and a 3. Here we're looking for a 1 and a 3. If it's a 3, that has to be 6 to make 9. If it's a 1, it has to be 8 to make 9. They're the only options it can be. So if it's an 8, that has to be 5. If it's a 6, that's got to be 7. Okay, let's carry on. We're looking at a few options here with a 10. 16 is a second top pair, and it can't be an 8 because 8 and 8 is 16. Also, because it's a number above 10, it can't be 1, 2, 3, 4, 5, or 6. The only numbers it can be is 7 and 9. This can only be 7 or 9. If that's a 9, that's got to be 3. If it's a 7, that has to be 5. Here we go now with 3 can only be 1 or 2. This can only be 1 or 2. Up here, if that's a 2, that has to be 4. If it's a 1, it has to be 5 to make 6. Now, we know that two numbers that are adding up to 10, it can't be a 5. Otherwise, it would be a 5 and a 5. Let's eliminate the 5. It's got to be 4 and 2 to make 6. That 2 then makes this the 1. That 1 means that this has to be 9. Because this is 4, this now has to be 6 in order to make the 10. Okay, let's carry on down here. If we subtract 9 from 13, we're only left with 4. So we're reducing a triple to a pair. So we know that with 4, it can only be 1 and 3. So I know the 1 can't go in here and the 3 can't go in there. So it's got to be 1 and 3. Because this is 3, then this has to be 9. Because that's 9, this has to be 2. So we've got, again, we're making inroads here very, very quickly. Two numbers adding to 3. I know that it can't be 1. It can only be 1 and 2, but I know that 1 can't go in that square because two numbers have to add up to 11. So this has to be the 2. This number has to be the 1. Because this is 2, then this has to be 9. So I can put that one in. Because we've established 1, this number here has to be 3. Because that's 3, this number here has to be 1, because you can't have the same number in any row or column. Plus, the only two numbers that go together is 1 and 3. 1 will make this then the 8. Being 8, this has to be the 5. Okay, we've now got a pair that's adding up to 14. It's got two options. It can't be 7. It can't be 1, 2, 3, or 4. So we can check it again. It can only be 5 and 9, or 6 and 8, or 5, 6, 8, 9. So let's put those in. 5, 6, 8, 9. 5, 6, 8, 9. And let's go off for the tangents. We know that it can't be 9 or 8 because this has to add up to 7. So I can get rid of the 9 and I can get rid of the 8. I can also get rid of the opposite pairs that will match. If it's a 9, it can't be. If it can't be 9, it can't be 5. If it can't be 8, it can't be 6. So we're left with these two numbers now. So if it's a 6, it's got to be 1 to make 7. If it's a 5, it's got to be 2 to make 7. With the 15, if it's 9, it has to be 6 to make 15. And if it's 8, it has to be 7 to make 15. So now that's one pass from the top to the bottom. Let's go vertical and work our way across. Two numbers adding up to 16 can only be 7 and 9. Can't be 8. Can't be 1, 2, 3, 4, 5, or 6. There it goes to show there. Because this number has to be 9, I know that that has to be the 7. This has to be the 9. Logic tells us on this row now that instead of looking for 3 numbers that are adding up to 18, we're only looking for 2 numbers that add up to 9. Because that's 7, this has to be the 2 to make 9. Okay, let's work our way down here. Now we're looking for a pair of numbers that add up to 6. Can't be the 3. So we know from experience that it can only be 1, 2, 4, and 5, or 1 and 5 pair, 2 and 4 pair. Let's put those numbers in. So we're looking at 1, 2, 4, 5, 1, 2, 4, 5. That's all it can be. Now, let's just take a step back to this one. Now that we know that this is 9 and these two squares have to add up to 9, if that's a 4, then that has to be 5 in order to add up to 9. If it's a 4, if it's a 5, it has to be 4. If it's a 4, it has to be 5, but we've already got a 5. So we know that 5 can't go there, 4 can't go there. We can eliminate the 4. If that can't be 4, this cannot be 2, because remember they go together in pairs. Now then, again, we're adding up to 9. If that is a 2, then that has to be 7 to make 9. And if it's a 1, then it has to be 8 to make 9. Okay, let's carry on and see if there's any other numbers that we can work out here. Here we've got two numbers adding up to 5. So we know that that can only be 1, 2, 3, and 4. So let's put them in. 1, 2, 3, 4. In here, it can only be 1, 2, 3, 4. But two numbers adding up to 8, we know that it cannot be a 4. So we'll eliminate the 4. If it can't be 4, this cannot be 1. There we go. We've already got a 3 established on this side, so we know that this cannot be 3. And if that cannot be 3, this cannot be 2. So we can eliminate the 2. We're now looking again for two numbers and that add up to 8. So if it's a 3, that's got to be 5. We've already got the 5. Eliminate it. It has to be 1 and 7. And for this to add up to 5, we've got 1. This has to be the 4. Because we've got 4, we can't have any more 4s on this row. So that has to be 6. We can also get rid of this 4. If that can't be 4, the one on the opposite side in a pair cannot be 2. If that cannot be 2, this one cannot be 7, because on this row here we were chasing a pair adding up to 9. So I can get rid of that 7. Okay. So because we've got 6 established, this has to be 1 to make 7. 1 means then that this has to be 3. We're only missing one number in this column. So 6 and 3 is 9. 9 and 7 make 16. 16 and 5 is 21. So this then has to be 9 to make up the 30. Okay. Let's have a look at this number here now with 42. If we add up these numbers, it will just show us what we're left in these two squares. So instead of trying to find now a run of 7 numbers, we're only working down now to a pair. So 6 and 9 is 15, and 4 is 19. That's 20, 21, 22, and 8 is 30. So we're actually looking at two numbers now that add up to 12. So we know it can't be 1. It has to be the 5 and the 7. Okay. Because it's 5, then this has to be 1, and it adds up to the 6. So we know we're getting near to the final finish now. 9 and 1 is 10. This has to be the 8. Because we've established a 7, this has to be a 9. That 9 makes this 7. That 7 will make this 5. Let's add up these numbers now from 41. We've got 9 and 1 is 10, 13, 18, 20, 25, 33, 35. This number here has to be 6. Okay, because we've established a 6, this has to be 7. Because that's 7, this has to be 8 to make 15. Because that's 8, this has to be 6 to make 14. Because this is 6, that has to be 1. And in that short space of time, I think you'll find we have now covered all of these numbers. So we've gone through the 3 and 4 option, how you can narrow down the option pairs. We've gone through a few 0 option runs. We've kept using the check button, but I'll use the check button again just to make sure we've actually got the final figure done. Yes, it has done. So what I want to do now is that I'm going to show you a couple of charts which will explain some of these runs. Okay, I'll put that up right now. Okay, here we've got the first chart that I'm trying, I'll explain what this is. This is all the possible pair combinations that you can get for Kakuro. As we mentioned at the very beginning, you can't have two because you cannot have 1 and 1. So when we look down this list, this is just showing you, as we started in the very first episode, the numbers that don't have any other options, which is the 3 and the 4, and the 16 and the 17. The numbers that we've got that have got two options are the 5 and the 6, and also the 14 and the 15. When you get into the numbers like the 7 and the 8, you can look down there, is that they've both got three different options that you can get, and also the same thing with the 12 and the 13. The numbers in the middle from 9, 10 and 11, they all have four options. Now, if you look at the structure of the numbers, it's easy to run through them, and we can just quickly go through and you get an idea of how it all works. 3 can only be 1 and 2, 4 can only be 1 and 3. 5 can only be 1 and 4 and 2 and 3, or remember it just as 1, 2, 3, 4. 6, because it can't be 3, can only be 1 and 5 and 2 and 4, or just remember it as 1, 2, 4, 5. With the 7, you've got the three options. It can then be 1 and 6, 2 and 5, 3 and 4, or just remember it is 1, 2, 3, 4, 5, 6. It obviously can't have 7 and 0. So 6 is the highest number that you can get, which is paired with the 1, and they're the only options with it. When you go to the 8, you can have 1 and 7, 2 and 6, 3 and 5. You can't have 4, because that would then be the same number in the same line, or you can just remember it as 1, 2, 3, 5, 6, 7. When we get to 9, 10 and 11, they've got four options with them. So you can see the run of the numbers there for 9. It can be 1 and 8, 2 and 7, 3 and 6, or 4 and 5, or just remember it as 1, 2, 3, 4, 5, 6, 7, 8. Same thing then with the 10 is 1 and 9, 2 and 8, 3 and 7, 4 and 6. It can't be 5, so just look at that as 1, 2, 3, 4, 6, 7, 8, 9. And the same will go down the other side. So I just wanted to show you these so you can understand, have a look at them, take a screenshot, print them off, just work out, and it's just an easy way of remembering these. And when you look at it, it just shows you the structure of what they can be. And also down there, it shows you that the numbers that have got the four options, the numbers that have the three options, the numbers that have got the two options, and the basics of the numbers that you can't have any other numbers. All you've got to do then is sort out which way around they go. And remember, because they're pairs, once you've established a number, it can only have one number on the opposite side of the pairs. So after knowing that, and after having a go at some of these basic puzzles, by now there should be nothing else that we need to teach you about pairs. That is everything that there is to know. Okay. Okay, this second chart that I want to show you, as you can see from the screen here, it's headed as the zero option runs. Now, what this just explains to you is that in the left-hand column, the length of the runs, in other words, we're just looking for three numbers from the top that add up to 6. There are no other options. It can only be 1, 2, and 3. All you've got to do is work out which order that they go in. Three numbers that add up to 7 can only be 1, 2, and 4. Just depends on which way around they go. And at the other end of the scale with the high numbers, we learn from the very basics is that 7, 8, and 9 add up to 24. 6, 8, 9 add up to 23. When you go a little bit further down, you can see now that if we add up 1, 2, 3, and 4, that gets to 10. So any time that the Kakuro is asking you for a target of 10 with 4 squares, there can't be any other options than those numbers 1, 2, 3, and 4 in whichever order you've got to sort out. Same thing with 11, can only be 1, 2, 3, and 5, no other options. The under end of the scale with 4, if they want 30, it's 6, 7, 8, and 9. For 29, it's 5, 7, 8, and 9. No other options can go in there. So when you look down at the very bottom, we'll work backwards a little bit now. If in Kakuro it ever asks you for a row of 9 numbers that add up to 45, then it's every digit, because when you add up all the digits 1, 2, 3, 4, 5, 6, 7, 8, 9, they add up to 45. So at the same token, anytime that if they can't possibly ask you for 45 numbers when it's only in 8 squares or 7 squares, these numbers will correspond that there's no other options. So in other words, any time that you've got to get a number 44, it has to be in 8 numbers, and it can only be all the digits except the 1. So have a look through this list. You can work it, and you can see the structure of how it all works. What we'll do is that in a future exercises that we'll go through all the runs that have got 2 options in them and 3 options, and you'll see soon how these structures work. Now, next time I'll just be doing an easy puzzle, and we'll be running through what we've learned so far, and then probably the next one after that we'll start stepping it up from the easy puzzles up to the next level. So once again, thank you for watching, and we'll catch you next time. Bye.